You know, when you're at home, you just flick a switch and the lights pop on. It's so simple, so reliable, you never even think about it. But what happens when your house is a pleasure craft? When it's floating in corrosive salt water and it's constantly vibrating and moving around? Well, that's what we're going to get into because, trust me, boat electrics are a completely different animal.
So here's our game plan. We'll start with why a boat is not a house. Then we'll dive into the hostile environment on the water. We'll juggle AC and DC power, solve the power puzzle, and navigate the grounding minefield. And finally, we'll see why this is one area you really don't want to mess with yourself.
So this really is the core question, isn't it? A switch is just a switch. The laws of physics don't change. But the application, the place where you're using that electricity, that changes everything. A boat is pretty much one of the toughest places you can imagine for an electrical system, and that fact shapes every single wire, every connection, and every choice that gets made.
Okay, let's get right to the heart of it. Why can't you just hire a regular electrician to wire up your boat like they would your kitchen? Well, the simple answer is that the two environments couldn't be more opposite.
Think about it. Your house? It's stable. It's dry, hopefully. You have one simple source of power coming from the grid, and you have a solid connection to the actual earth for grounding. A boat is the exact opposite. It's always moving, always vibrating. It's in a wet, salty, super corrosive environment. You're juggling a whole bunch of different power sources, and, this is the big one, you're floating. You have no direct connection to the ground. And that little detail is going to become a huge deal in a few minutes.
So because of that hostile environment, every single component has to be engineered to a way, way higher standard. We're talking about everything, right down to the wires themselves. It's all about resisting that constant attack from the sea.
And this slide just illustrates that perfectly. The wire in your walls is probably a single solid piece of copper. If you put that on a boat, the vibration would snap it in no time. So marine wire uses superfine strands of copper all bundled together for flexibility. But look closer, it's tinned. Each one of those tiny little strands is coated in tin. Why? To stop salt water from creeping up inside the insulation and causing a failure miles from shore. It's a tiny detail that makes all the difference in the world.
All right, so the materials are different, but the power itself is different too. You see, unlike a house, a boat is essentially running two completely separate electrical systems at the same time. You've got AC and you've got DC.
So your DC system, that's the boat's lifeline. It's low voltage, usually 12 or 24 volts, and it runs off your batteries. It powers everything that you absolutely need to be safe and operational when you're offshore. Your navigation gear, your bilge pumps, your radios. Then you have the AC system. That's for convenience. That's your at-home power for the microwave or the TV. And it only works when you're plugged into the dock, running a generator, or using a device called an inverter to turn that DC battery power into AC.
Okay, so if you have two different systems, where does all the power come from? At home, it's easy, right? You just plug into the grid. But on a boat, you are constantly managing this complex puzzle of generating electricity, storing it, and using it, all from a bunch of different sources. When you're tied up at the dock, you've got simple shore power. But the second you cast off those lines, you become your own personal power company. Your engine's alternator is charging the batteries while you motor. You might fire up an onboard generator for big AC loads. You could have solar panels or a wind generator silently topping things off. And right at the center of it all, you've got these big battery banks storing all that energy. It's a constant balancing act, a little energy ecosystem you have to manage.
This really shows the two separate worlds a boat lives in. On the left, you're tethered to the dock. The power flows in, goes through your safety devices, and is grounded all the way back to the earth at the marina. But on the right, you're offshore. Now your inverter or your generator is the source of the power. Your system has to create its own internal ground because there's no earth to connect to. You're basically a little self-contained floating power station.
All right, let's talk about the most complex, the most critical, and honestly, the most misunderstood topic in marine electrics: grounding. This is where the stakes get incredibly high, and this is where a boat is absolutely nothing like your house.
So, first you have to understand the main bad guy here: galvanic corrosion. To put it simply, if you stick two different kinds of metal in salt water and connect them with a wire, you literally create a battery. And in that battery, one metal, the less noble one, gets eaten away to protect the other. Get your grounding wrong, and you can accidentally turn your very expensive bronze propeller into a dissolving anode, sacrificing itself to protect a piece of stainless steel. It's not good.
So, to fight this, the boat's DC system is grounded to the water in a really specific way. If you look here, you can see the negative side of the system is connected to the engine block. The engine, in turn, is connected to the propeller shaft, which is in the water. This creates one single point where the whole DC system touches the sea. And having just one point is absolutely crucial for stopping stray currents from running wild.
But things get so much more complicated the second you plug into shore power. Suddenly, that green ground wire in the shore power cord connects your boat's underwater metal to every other boat in the marina. It creates a potential superhighway for those little corrosive DC currents to travel between boats. And that is why a device like a galvanic isolator is so important. It acts like a gatekeeper. It blocks those tiny, destructive DC currents, but still lets the AC ground do its safety job if there's a major fault. And the real-world danger of getting this wrong is what people call a hot marina. If just one boat has faulty wiring and is leaking current into the water, your boat can become part of a circuit. And if you don't have the right protection, that stray electricity can eat away your propeller or your through holes in just a matter of weeks. We're talking thousands and thousands of dollars in damage really fast.
So, when you add it all up, the harsh environment, the two separate AC and DC systems, this absolute minefield of grounding, it all points to one single, inescapable conclusion. This is not a job for a weekend warrior or even a standard residential electrician. The stakes are just too high. And you don't have to take my word for it. Just look at this warning label. It's an example from the American Boat and Yacht Council, or ABYC. The warnings are so blunt because the consequences of a mistake are so severe. On a boat, you're literally surrounded by water, which massively increases the shock hazard, and you're living on top of tanks of fuel and banks of batteries, which makes the fire risk just terrifying.
Here's another perfect example: ignition protection. This is exactly why you can't just run down to the auto parts store and grab a new starter for your boat's engine. A tiny little spark from a non-marine part could ignite gas fumes in the bilge and, well, you can imagine. Every single electrical component in an engine space must be ignition protected by law. It is literally a life or death standard.
And this right here, this is just a tiny little sample from the absolute bookshelf of standards a real marine electrician has to know inside and out. Each of these codes, E11, A28, is a whole world of specialized knowledge. This isn't just about making a lights turn on. It's about designing a comprehensive safety system from the ground up.
So, we'll end on this thought. The electrical system is the nervous system of your boat. It gives you comfort, sure, but way more importantly, it ensures your safety. Understanding these unique challenges is key, and respecting the complexity is just absolutely essential. Because when you're out on the water, you just can't afford to get it wrong.